Hello everybody. Today we're going to be talking about basically making a mathematical conjecture a little easier by using Java and object-oriented programming practices to automate it, basically, sort of. You could also think of it maybe as like a little sort of nerdy game, I guess. Okay, so if you're unfamiliar with the Collatz Conjecture, this is what it looks like in stepwise notation. I'm assuming everybody here is familiar with, basic sort of algebra. I don't expect everybody to be familiar with what mod is, or modulo. So the essence of modulo is when you take a number and you modulo it, the resultant from that calculation will be either 0 or 1, or it could be another number. It's basically the remainder of that division. So if you say n, right here, n divided by 2, or n mod 2, or sorry, mod 2, yeah, there's the mod 2. This is n divided by 2. Disregard what I just said. So if you take n mod 2, and the number happens to be even, it will come out 0. And if that happens, you want to divide that number by 2. And then if you do the same thing and it's an odd number, it'll come out 1, because the remainder will be 1. And when that case happens, you do multiply by 3 and add 1. And then you keep doing this until you reach 1 again. This works for every number in the known integer set. I believe it also works with decimal numbers of any kind, but for our purposes today we're just going to be doing integers, just to keep it simple, and because nobody wants to deal with doubles on their first try. So with that, we're going to explain some basic object-oriented programming principles. So the first thing you need to know about object-oriented programming, we're using the language Java specifically today. A class is just a collection of methods, variables. Basically, it's just the outline of what everything is. They contain a constructor, a getter, setter, two string methods. Those are all normal things that you would find in a class. A class you can also think of as just basically the file, the file that you're going to be programming in. We'll get into what classes mean a little more in just a second. So basic data types, if you're unfamiliar, in Java we have the string data type, because this Java is a strongly typed language, so basically you have to define every data type that you're going to use, and you can't really mix that well. So this means that it can't just interpret what you mean by putting something like this. So like example string, this is what a string looks like in pretty much every language. But you have to tell Java that it's a string too, so that it knows. We also have integer, which is defined by just int, int, lowercase. That's a 16-bit number, and that's an example of an integer right there, just 12, 11, 12, 10, any number without a decimal. A character, or char, C-H-A-R, lowercase, is an 8-bit letter, basically, any kind of just character, and it's usually denoted by single quotes, and it's usually just a letter. And then we have double, that's a 64-bit number. Basically, pi approximation is a double. Float is the same thing, it's just a 32-bit number. That's 3.1416, smaller, basically. It's about half the length of a double that you can do. A long is just a longer integer. So you can do a 64-bit integer, that it's a bad example, but 9001, it's over 9,000, obviously. It's just a longer integer. That's pretty much all that is. We got Boolean. That's just true or false. Pretty simple. And then a byte. We're not going to use that today, but I just wanted to mention it. It's just an 8-bit. The technical definition is an 8-bit 2's complement, something, blah, blah, blah. It's wildly irrelevant to what we're doing. Okay, so objects in Java, in but I'm just going to keep saying Java because it's easier. These all apply to every object-oriented programming language, but Java is what I'm using. Okay, so my name is Chris, obviously, and I'm an instance object of class man. When we say human, being man or woman, or any other gender for that matter, but for our purposes today, man or woman, just kind of mean you, your friend, I, they're all classes. We have a physical existence, while a class is just literally a logical definition or blueprint. It's kind of the difference between an architecture project. You have a blueprint, and then you got the building that you built. The class is the building. The object is the building. The class is the blueprint. Got that backwards. So, objects, like I said, are what result from using the class or the blueprint. So, an example in Java of making a new variable of me in class man is man, Chris, equals new man. And this is standard for every time you make a new object, pretty much, in Java. That's extremely standard. Okay, so inheritance, we're not really going to use this today either, but I'm just going to talk about all of the principles that go along with object-oriented programming, because I think it's still good to know whether or not we're going to use it today or not. Inheritance is just like it says, a feature that allows code reusability and that allows a class to use properties from other classes. So say, like the example I have here is a human being class, which has properties of hands, legs, eyes, mouth, blah blah blah, and functions, walk, talk, eat, see. Man and woman are also classes within the same project, so you can basically include the methods from human being into man and woman by extending that class. That's the key word you would use, is extends. So man extends human being, woman extends human being, and they would inherit everything from those classes, from that class, using inheritance. It's fairly simple. Not too. Everybody thinks inheritance and polymorphism and all that is super complicated. It's really not. Abstraction basically is sort of only what you need to see outside of the class is what you're going to see. You don't need to see all the nitty-gritty underneath. The example I have here is the same thing. Human beings can do all that, walk, talk, hear, and eat, but the details that we have of the muscles and the biology we don't think about every day. So we're abstracting the underlying mechanism. Same with Java. It's just what it does. It's not how it does it. Yeah, that's basically it. Encapsulation is where we just hide unnecessary details from the user of the class. Basically, yeah, like I said, we call from our phone and we select the number and press call. But the entire process of calling, or what happens from the moment we press or touch the call button to the moment we start having a phone conversation, is hidden. Yeah, that's extremely true. Usually encapsulation is used more in terms of variables to classes. And encapsulation can also be where getters and setters come into play. So if you have a private variable, basically you'll want to use a getter and setter because that variable is encapsulated so that only the class... It's a form of control of how you can use certain things, basically. Polymorphism is basically a way to redefine the way that something works. So if you have I meant to put an image here with an example, but if you have a method or function that has 2 parameters, you can also create another method with 3 parameters, and it will be a completely different method. Well, it's the same method, but it changes how the method works. That's called overloading. You can also do something called overriding, which is where the method is in another class, and you override that method in the class that it's extending and make it do something different. And okay, so this is basically everything you need to know for basic object-oriented programming. All of these concepts go much deeper. I'm just giving you a very brief overview of everything so that you can kind of see and understand a little bit better about what I'm doing here. Alright, for the second part of the video, I am going to basically, with you guys, write out the program, basically. Alright, so we're also going to go over some features of IntelliJ, which is my preferred IDE of choice. So here's a new project window right here. And we're going to make a new Java project. Yeah, we just hit next. Okay. Nope. Well, no, that's fine. Alright, so we're going to call the project Collatz Conjecture Tutorial. Okay, and yeah, that's just going to save to the desktop. That's fine. There we go. And that, for some reason, opened on my other monitor. There we go. Okay, so here we have the project file structure. So basically, everything's going to go in here. It's a source folder. I'm going to create a new Java file, Java class, and I'm going to name it Conjecture. Okay, there we go. Okay, so right now I'm going to make that a little bigger. How do you, what's the, there we go. Okay, so we need a few things to get started here. The first thing is a main method. So the main method is what some people refer to as the driver of the project, which basically means it's the thing that runs first, or the thing that runs at all, because if there's no main method, it probably won't run unless you tell it to. Okay, so the basic way to do that in Java is by doing public, which means it's visible outside the class. Static, which means it's only accessible to other static things. Void means it doesn't return anything, and then main. And then this is just standard stuff here that we're not going to get into right now. String args. Okay, that's our main method. And I'm going to add a comment above this that says it's the main. I think it's that. Yeah, there we go. And we're just going to say param args main method. That's pretty standard here. You always want to do that. Comment your code. It just makes things a lot easier. Okay, so I am going to take a few things here, and we're going to basically we're going to go over printing. So when you run the main method, you want it to print something because we want this to be reusable and just, you know, like sort of like a tool basically, or a game. So you want it to continue running. So now that we have the main method, we're going to create a run method, public static void run. Okay, there's your run method. Alright, and then after that I'm going to have a method that actually does the calculation. So public static void calculate. Alright, there's our calculate method as well. And then I want, this is just a sort of semantical thing, just to hold a command. Public ic static void end, which will end the program when we want it to, and for that I'm just going to go ahead and fill that in right now. That's just system dot exit with status code 0. Basically all that does is just end the Java program. So system exit 0 means there's no errors, it's done. Okay, so that's that. So now we're going to go up and fill in the main. And then we'll get into the meat of the program. So I have some pre-written out things just so I don't have to do everything here. I'm just going to copy those and then paste those right there. Okay, so these are called system outs or system prints, however you want to look at them. I'm going to give you an example of a system print. So I think this works in IntelliJ as well. So you do SOUT and then tab, and then we'll give you a system out print line. That's a little life hack there that I've learned. And we're going to make this hello world. Because this is your first Java program, you can't really have anything without a hello world. That's just whatever, you know. So we're going to run this real quick. I'm going to build it, which compiles everything. You want to compile often because Java is a compiled language, so you want to make sure that everything's kosher there. So now we're going to run it, and it will open up a little pane down here and show you that everything that we just put in here has printed. So that is what we want to see. Okay, so I'm going to get rid of this. We don't need that at the moment. So basically what I just made it do is print out instructions, and print ln means it goes to a new line when that command is finished. So if I just said print, all of this would print on the same line, which we don't want. And I just realized these are wrong, so we need that to be n/2, and then times 3 plus 1. Okay, there we go. There's that. So now what we're going to do is put this in something called a try block, which will catch any errors that may happen during the running process. This is not really something that you need to worry about. This is just something that makes the program more usable. So we want the two methods to run. So we want it to run first. Or no, sorry, we want it to calculate first and then run. So actually, I'm gonna come back to that. We're gonna come back to this part. Let's actually do the run method first, so that we can see what things are doing before we get into all of that other stuff. Okay, so here is an example of something called a local variable. So a local variable is only accessible to this part of the program, this method. When this method is going, that variable is accessible. Any other time, you can't touch it. So the variable we're going to put in here is called a boolean. Boolean running equals true. All right, so that just means the program's running. We're going. I am also going to put a global variable up here. Global means it's accessible to everything. So we're going to call that scanner. Scanner is what allows Java to get user input. We're going to call it scanner equals new scanner. And that's going to be system.in. Pretty simple. Okay. Now I'm going to, basically what I'm going to do is going to hit Alt-Enter, and that's just going to import the class that I need for that to work, because that's an external class. Okay, there's that. Alright, so now we're going to put this in something called a while loop. And what the while loop does is it's kind of like, it's exactly what it sounds like. It's while something, do this. So while, but it's not a while do loop, which we're not going to cover today. So while running and this right here means that while this thing equals true, because it's always going to be true right now. But you could also say running equals true, and that would basically be the same thing. And now it's going to tell me that it can be simplified to running, which is what I had in the first place. So we're going to do that. Okay, so a couple more system prints I have preset here. Just grab those. That way I'm not spending a ton of time talking about or talking over myself typing. Just make that easier. Okay, so enter 1 to calculate another number. Calculate a number. And then enter 0 if you want the program shut down. Fairly standard. 1 and 0, binary, always fun. So I'm going to say long, because we want that number to be big, 64-bit to be specific, R. I don't know, just like letter R. And then we're going to call that, or we're going to set that equal to SC dot next int. Why is it saying that I can't do that? Ah, my bad. Forgot to define public static. There, that should fix our scanner problem. There we go. Alright, and I did that because this method is static, and again, static can only be accessed by other static things. And then public, it could be private, I just made it public for no real reason. Okay, so next we're going to do an if statement. So semantically, if something, then do something. So if, and then we put our condition, if R equals 0. We do double equals, that's just the syntax for if statements. There's no real way around it. Okay, so if R equals 0, then we're just going to end. Pretty simple. Else, that means otherwise, we're going to calculate. Alright, there you go. So that's our run method in a nutshell. It's pretty straightforward, not really too much to say about it. Alright, now we're going to do the hard part, which is the calculate method. So this is going to be a long one, but it's the meat of the program, so we need it to be kind of long, which is fine. So for the calculate method, okay, so another local variable, boolean calculate equals true. There we go. And then I'm also going to put a long counter equals 0, because we want it to count how many times that it does something. So now we're going to try something. Literally, we're going to try system out. Please enter an integer. Please enter an integer. There we go. My bad. We need to have one more variable here. Int n equals, well, we're just going to say int n. Alright, so n equals scanner dot next next int. There we go. And that's going to get the user input from that thing there, from the print statement. So next, after that, so now we're going to say while n is bigger than 1, then we want to do some stuff. So we're going to do a couple of if statements here. So we're going to say if n % or mod 2 equals 1, then we want to do something. Now we want to do else if n mod 2 equals 0, then we're going to want to do something. And then on the other case that we've hit 1, oh, I'm sorry, I made this condition wrong. This should be 0. And then else if and actually just n equals 1 is what we want. We don't need to mod it. And that's pretty simple. We just want to calculate equal to false. Oh, sorry. There we go. Okay, so if n mod 2 equals 1, otherwise known as odd, then if n mod 2 is 0, otherwise known as, actually I should put that comment after it, not above it. Even, and then obviously 1 is our ending end loop. Okay, so if it's odd, then we want to by the conjecture stating if it's odd, we want to multiply by 3 and add 1. N equals 3n plus 1, except not 3n. We want to do 3 times n because it doesn't know what 3n is. And then I'm going to space that out a little more nicely. Cool. So that's going to do 3 times n plus 1. Pretty simple. All right, next we're going to do even. So if it's even, we want to do n equals n over 2. Done. Pretty simple there as well. And then, oh, I forgot. After each of these ones, I'm going to want to system out, and then we'll print in. That way we know what number we're at in the thing. Okay, and then at the end of this loop, after everything, we're going to say counter plus plus, which will increment our counting variable here. Alright, what was this? Oh yeah, try, and now we need a catch. We want to catch an exception of an undefined type. And then all we want to do there is just say which most of the time, anytime there's an exception, it's just going to be, it's probably not a number, so that's not a number. Please try again. that's about it there. Oh, I also want to, right after this while loop, we want to reset everything. So we're going to say, do a system out to tell you that it took, and then we're going to insert the counter variable there, because you can, with an integer, you can actually just have it print what that is by just placing the variable there. And then steps to get to the number 1. There we go. And I am bad at grammar, so I put to'd, it took. And then after that, we just want to say counter equals 0. And that'll reset the counter back to 0 again. That's just a failsafe. It'll probably do it up here as well, but just want to make sure. Okay, so that's that method right there. And that is actually the meat of the entire thing. So now we want to go up and do the main method. All right, here, and this is the structure of how things are going to work. So we're going to say try. We're going to try to calculate, because in calculate down here, as you can see, it says please enter a number, please enter an integer. That is the first step that you want to actually calculate something, because when you open the program, you want it to immediately do what you want it to do. You don't want to have to choose if you want to end the program right then. So we don't want to do run first. So after calculate, then we do run. So we want to keep the program running. That's the point of the run thing. This will run once, and then if you just had that with no run, actually I'll demonstrate that. We're going to comment that out. I'm going to quickly put a catch here. Same thing, exception E. And then we're just going to say system out. That's not what we expected. Please try again. And then after that, actually, no, I'll wait on that too. Okay, so this is done now. This will run once, and I'll show you that. I'm going to compile it real quick to show that it compiles. There we go. We're going to run it. All right, see? Right down here, the print statements, what it is. We're going to click in this box. Please enter an integer. I'm going to enter the integer 27 because I know, because I looked on the Wikipedia page, that that's a long one. So 27 should go 111 times. And oh boy. Uh-oh, I think I did something wrong. Stop, 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 stop. How do I stop it? Terminate. Okay, hold on. What did I do wrong? It's not stopping at 1. That's why. I'm actually going to not make this an else if. I'm just going to make this an if. Maybe that'll fix our problem here. Oh, wait. That actually should be 1, I think. Let's try that again. Okay, so we're going to say 27. There we go. Yep, it was this. I, for some reason, put 0 instead of 1. I'm not sure why I thought that would work. Okay, so see, right there. It took 111 steps to get to 1. And as you can see, there's all the numbers that it iterated through. Green in IntelliJ means that you entered a number, and these are the outputs. All right. that's that. And as you can see, it finished with exit code 0. It did not keep running. So get rid of the run box. Now we're going to go back up to the main method here, uncomment run. And then after here, we're also going to put another run just to keep that running in case an exception happens. And now we're completely done. We run it again, demonstrate that it works. Right, so please enter an integer. I can enter a really big number, like that. And that took 177 steps. I don't even know what number I entered. Okay. And as you can see, or if you would like to exit, enter 1 to calculate another number. So we're going to enter 1. Cool. Please enter an integer. We'll do 27 again. Took 111 steps. Cool. Can do it again. We'll do, I don't know, 57. That one took 32 steps. Okay, cool. And now we're done, so we'll say 0. And there you go. Process finished with exit code 0. Pretty simple. Now I will show you where this program breaks down. So if you enter a number that is larger than a 64-bit integer, so I'm just going to type a ridiculously long number here. Like really, really, really long. Okay, I think that should be sufficiently long. So if you enter a number that's bigger than a 64-bit integer here, long basically, it will crash because Java can't handle numbers that big. For that, you have to use something called big integer. And that's a separate class that is a tool for using really, really huge numbers. But for the purpose of this tutorial, I didn't want to do that because that's confusing and you have to know some things that are slightly outside of the scope of what we're doing right here. So as you can see, number that big, input mismatch, and it's just way too large. It just can't do it. And see, the exit code has changed because it's an error, exit code 1. But that is the essence of the Collatz conjecture. Pretty simple.